Welcome back. Let's learn how to simplify variable expressions using the distributive property. Alright, so previously in algebra, we looked at the properties of addition and multiplication and how we can use them to help us simplify variable expressions. However, there is one more property that we need to look at, and it's sort of in a class of its own, and that is the distributive property. This is a very important property that you will make use of a lot throughout algebra and future math courses as well. And we're going to start by taking a look at how it applies to regular, real numbers, and then we'll see how the property applies to variable terms and expressions. Alright, and so the distributive property looks like this. For three real numbers, a, b, and c, it says that a multiplied by the sum, or the addition of b and c, is equal to a times b plus a times c. In other words, what's going on here is a is being distributed through this quantity. Everything that you see between these two parentheses, both b and c, get multiplied by a, right? We have a times b, which gives us this term of a times b, and then we multiply a by c, and that's how we get this second term. We have plus ac. All right, so a gets distributed to both of those numbers being added together in those parentheses. Now, another way that you could express the distributive property is like this. It would also be true in the reverse order. If you had b plus c in parentheses and then multiplied by a, you can still distribute that a through this quantity and multiply a by b and get ba, and then multiply a by c to get plus ca. Alright, now these two results are the same because remember from your multiplication properties that the order of multiplication does not matter, so a times b is the same as b times a, and a times c is the same as c times a. Alright, so it doesn't matter if the number that you are distributing through a quantity is to the left or to the right of that quantity, the property still holds true. In each case, the term outside the parentheses is multiplied by each term inside the parentheses. That's how I like to think of the distributive property. That a is on the outside, so it gets multiplied by everything inside, and it doesn't matter if that a is to the left or to the right of the quantity, it still gets distributed all the same. Okay, so now let's take a look at an example where we're actually working with some real numbers for a, b, and c so that you can see that the distributive property is true. And so we'll start with this example right here, where a is equal to 2, b is equal to 3, and c is equal to 4. Let's use these three values for a, b, and c in this form of the distributive property and show that it is true. So we'll have 2, which is our value of a, multiplied by the sum of b and c, where in this case b is 3 and c is 4. We are saying that that would be equal to 2 times 3 plus 2 times 4. All right, so we'd have 2 multiplied by 3, and then we would add that to 2 times 4. We take that number on the outside and multiply it by both of the numbers inside the parentheses. All right, now simplifying, let's see if both sides of the equation result in the same value. Starting with what's inside the parentheses, 3 plus 4 is 7. So we have 2 times 7 on this side, and that will be equal to 2 times 3 plus 2 times 4. 2 times 3 is 6, so we have 6 plus 2 times 4, which is 8. So on one side, we have 2 times 7, and on the other side, we have 6 plus 8. Two different calculations, but both of them produce the same result. 2 times 7 is 14, and so is 6 plus 8. They are both equal to 14, so the distributive property clearly is true. And we can also test that it is true if it's written in this way as well, if we put the number of a to the right of the parentheses rather than the left, like we did in this example. Let's try doing it the other way with some different numbers. In this case, a is equal to -1, b is equal to -5, and c is equal to -2. So you're going to get to see here that the distributive property also still works when you were dealing with negative numbers. So if we set it up this way, in the parentheses, we're going to have b plus c, where b is -5 and c is -2, and that's going to be multiplied by a, which is -1. So we're multiplying by -1, and we're saying that that would be equal to multiplying -1 by each of these numbers. So we'd have -5 times -1, I'll start by writing that down. We have negative 5 times negative 1, and then we would add that to negative 2 times negative 1. All right, so we have negative 2 times negative 1. And so now if we simplify here, we should find that once again, both sides of the equation will be equal. Starting over here, negative 5 plus 2 is negative 7. So we have negative 7 times negative 1, and that will be equal to negative 5 times negative 1 plus negative 2 times negative 1. Now, negative 5 times negative 1 is positive 5, so we have 5 plus negative 2 times negative 1, which is positive 2. And then, simplifying further, negative 7 times negative 1 is positive 7, and so is 5 plus 2. Right? 5 plus 2 is 7, so both sides of the equation are equal to the same thing. So the distributive property is true. You can distribute a number outside a set of parentheses into the parentheses by multiplying that number by each of the numbers inside the parentheses. Okay, so that's how the distributive property works. But as I mentioned at the beginning of this lesson, the distributive property not only applies to real numbers, but it also applies to variable terms and variable expressions. And it pretty much works exactly how you would expect it to. What we will do is distribute any term outside a set of parentheses by multiplying that term by each term inside the set of parentheses. And then after we perform that multiplication, we want to be on the lookout for any like terms and combine those like terms. That is how we will fully simplify a variable expression that involves the use of the distributive property. So for example, here I have 3 different variable expressions where we can use the distributive property to help us simplify. Starting with the first one here, we have 3 multiplied by 5x minus 3. What we can do is distribute that 3 into this quantity by multiplying it by both of those terms. We take the outside value and multiply it by each inside term. All right, so we will multiply 3 by 5x, and we will multiply 3 by negative 3. Doing so will give us 3 times 5x minus 3 times 3, right? Since we have a minus here, you would subtract 3 multiplied by this 3. Another way that you could write that is to say that we have plus 3 times negative 3. So you can keep that negative with this 3 and add 3 times negative 3. It would do the same thing, but no matter how you do it, make sure that you multiply that outside term by both of the inside terms of the parentheses. Then after that, you just want to make use of your multiplication and addition properties that we looked at in previous lessons. To further simplify, you want to multiply 3 by this variable term of 5x by multiplying it by the coefficient and keeping that variable part. All right, so 3 times 5 is 15, so we get 15x for the first term, and then we're adding 3 times negative 3, and 3 times negative 3 is negative 9, so really we would be subtracting 9. All right, so that would be the simplified form of this variable expression with the help of the distributive property. If we move on to our second variable expression here, this time the term on the outside of the parentheses is to the right of the parentheses, but it doesn't matter. We can still simplify this variable expression using the distributive property. We will multiply 2 by both of these inside terms. We'll multiply 2 by 2y and then multiply 2 by 7. And so if we do that, we will get 2 times 2y plus 2 times 7. Now multiplying this constant by this variable term, you want to multiply 2 by the coefficient. So 2 times 2 is 4, and so you get 4 times y, right? You want to keep that same variable part of y, and then we know that 2 times 7 is 14, so we get 4y plus 14. All right, so that would be the simplified form of this variable expression using the distributive property. And then finally, if we take a look at this example here, this is another situation where we can use the distributive property to simplify a variable expression. We have a negative sign in front of a set of parentheses that encloses 3a plus b. Now, that negative sign out front, what that represents is multiplying both of these terms by negative 1. All right, so we would distribute that negative 1 through this quantity. We would multiply it by each term. All right, you'd multiply negative 1 by 3a, and you'd multiply -1 by b. Doing that will give us -1 times 3a plus -1 times b. All right. Now, -1 times 3 is -3. So this is equal to -3. And then you want to keep that same variable part of a. And then for our second term, we have -1 times b. The coefficient of b would just be 1. So you'd have -1 times 1, which is -1. So nothing really changes here. This is -1b. But we typically don't write minus 1b. Instead, we'll just write minus b. And that means the same thing. All right, so that right there would be the simplified form of this variable expression. Now, a little trick here, when you distribute -1, or the way that I like to think about it, is when you distribute a negative sign in front of a set of parentheses, you can do it really quickly by just changing the sign of each term inside the parentheses. All right, so in this case, since we have a negative sign in front of these two terms, 3a and b, the way to quickly distribute that negative is to just change both of these positive terms to be negative. And you'll see that's exactly what we have down here, -3a and -b. Okay, so when you just have a negative in front of a set of parentheses, a trick for distributing quickly is to just change the sign of each term inside the parentheses. Okay, but that's how we can simplify variable expressions using the distributive property. The same rules apply here that apply to real numbers. And so to sort of close out this lesson, I want to take a look at some more examples of using the distributive property to simplify some variable expressions. In particular, some variable expressions that are a little bit more complicated and involve a little bit more work than what we did right here. And first up, we have 4 multiplied by this quantity that has the terms x squared plus 3x minus 1. All right, and so you might have noticed here that these parentheses have 3 terms inside of them. Something that you want to know is that the distributive property still holds true, or it can be extended, when there are more than just 2 terms inside a set of parentheses. Okay, so it's all right that there are 3 terms here. We can still use the distributive property. It's just that there's an extra step. We have another term that we need to distribute our outside term to. We will multiply 4 by all 3 of these terms inside the parentheses. Okay, so it wouldn't matter if there are 4 terms, 5 terms, 6 terms. You can distribute a term on the outside into that quantity or into those parentheses. All right, so that's exactly what we're going to do here. We're going to distribute 4 through this quantity. So we're going to multiply 4 by x squared and then multiply it by 3x and then multiply it by -1. All right, so we'll have 4 times x squared and we'll add that to 4 times 3x, and then we'll add that to 4 times -1. All right, we just multiplied 4 by each of those terms. Now simplifying, using our properties of multiplication, you want to multiply 4 by the coefficient of this variable term. In this case, it's just x squared, so the coefficient is 1. 4 times 1 is 4. So what we'll have here is 4x squared. You want to keep that same variable part. And then 4 times 3 is 12. So we will have plus 12, but don't forget that variable part of x. So we have 12x. And then 4 times -1 is -4. So we have -4 on the end there. And that's it. That would be the simplified form of our variable expression. Now there was the potential here that we might have some terms that we needed to combine before finalizing our answer. But if you look at our 3 terms here, all of them are completely different terms. None of them are like terms. They all have different variable parts, being x squared, x, and then nothing for the constant term. So none of them can be combined. This expression is as simple as it can get, using what we've learned so far. Okay, but you do want to be on the lookout for like terms. Let's take a look at another example. Hey there, real quick, before we get to the next part of this lesson, if you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's get back to the lesson. Here I have another variable expression that we can simplify. We have 6 multiplied by the quantity 3z plus 2, and then after that we are subtracting 10z. All right, so this term on the end here is not affected by the distributive property. All right, you're not going to multiply 6 by all 3 of these terms. You're just going to multiply 6 by what is inside the parentheses. All right, the distributive property does not reach out beyond what is inside a set of parentheses. Okay, so we will multiply 6 by 3z, and we will multiply it by 2, and that's it. We will just add on that negative 10z onto the end. All right, so here's what we'll have. We'll start with 6 multiplied by 3z, and then we'll add that to 6 multiplied by 2. But don't forget about this term on the end. We are also subtracting 10z. All right, don't multiply that by 6. Once again, 6 only gets multiplied by the terms inside the parentheses. All right, now simplifying, we'll have 6 times 3z. You want to multiply 6 by 3, and you'll get 18. And then you want to keep that same variable part of z. So we get 18z, and then plus 6 times 2, which is 12. So we have plus 12, and then we still have minus 10z on the end. Now, looking at our terms here, do we have any like terms? Well, in this case, we do, right? 18z and negative 10z have the same variable part, so those are like terms that we can combine. You want to add their coefficients and keep the same variable part. 18 plus a negative 10 results in 8, so this is equal to 8z plus 12. And now we have fully simplified this variable expression. 8z and 12 are not like terms, so this is our final answer. Okay, let's take a look at another. Here we want to simplify 2 multiplied by the quantity 5x plus 1, and then add that to 3 multiplied by the quantity x minus 7. Okay, so now in this example, we have 2 cases where we can apply the distributive property, and it's important that you make sure you multiply the right number by the right terms. Okay, 2 is going to be distributed through this quantity, so you're going to multiply 2 by 5x and 1, and 3 is going to be distributed through this quantity. You're going to multiply 3 by x and negative 7. You're not going to multiply 2 by anything over here, and you're not going to multiply 3 by anything over here. These are 2 completely different sets of instances where you can use the distributive property. Okay, so let's use the distributive property and simplify this variable expression. We're going to multiply 2 by 5x, and then multiply 2 by 1, and we'll multiply 3 by x, and then 3 by negative 7. All right, so here's what we'll get. We have 2 times 5x plus 2 times 1, and then plus 3 times x, and then plus 3 times the negative 7. All right, we multiplied 2 by these 2 terms to get these 2 terms, and we multiplied 3 by these 2 terms to get these 2 terms. Now simplifying further, 2 times 5 is 10, and then you want to keep that same variable part of x. So this is equal to 10x, and then 2 times 1 is 2, so we have plus 2. 3 times x, you would be multiplying 3 by the coefficient of 1, which is just 3. So you get plus 3x, you want to keep that same variable part, and then 3 times negative 7 is a negative 21. All right, now we're not quite done yet, because if you look at our resulting terms, we have 2 pairs of like terms. We have 10x and 3x that both have the same variable part of x, and we have 2 constant terms of 2 and negative 21. All right, so let's combine our like terms. We're going to combine 10x with 3x and 2 with negative 21. So adding the coefficients of our variable terms, 10 and 3 become 13. So we have 13x. You want to keep that same variable part. And then 2 minus 21, or 2 plus negative 21, is negative 19. So we have minus 19, and that right there is the final answer. That is this variable expression simplified with the help of the distributive property. Okay, let's take a look at one final example for this video. All right, so here's our final example, and this one's really going to test your skills and if you fully understand how the distributive property works. Because if you look at our variable expression, there's more than just one set of parentheses. In fact, we have a set of parentheses inside a set of parentheses. So this seems really tricky and you might not know where to start. But in situations like this, my recommendation is to start simplifying the furthest into a set of parentheses that you can. So first of all, you see this set of parentheses, but inside that set of parentheses is another set of parentheses. So that's going to be our focus to start. Notice that we have 7, or technically it's -7, being multiplied by both 4 and -5x. All right, that is an instance where we want to use the distributive property. So let's start with that. We'll multiply -7 by 4, and then multiply -7 by -5x. All right, we're going to keep everything else the same to start. So we have -9x plus 2 times x, and then you want to add -7 times 4. All right, so we have plus -7 times 4, and then you'll add that to -7 times -5x. So we have -7 times -5x, and that is all inside those parentheses. Okay, now let's simplify what we have here before we do anything else. -7 times 4 is -28. So if we rewrite everything again, we have -9x plus 2 times x minus 28. And then we have -7 times the -5x. You want to multiply -7 by the coefficient. -7 times the -5 is positive 35. So we have plus 35x. And that is the last term inside those parentheses. Now, you have a couple options. At this point, you could move on to doing the distributive property again, because you have this 2 being multiplied by this quantity. But something that we can do here, notice that in this set of parentheses, we have 2 like terms. X and 35x both have the same variable part. We can combine those within this set of parentheses before we use the distributive property. That's going to save us a little bit of work later on. Instead of multiplying 2 by both of those terms and then adding them together later, because they still would be like terms, we can just do the addition now and then only have to multiply 2 by 2 terms in this quantity instead of 3. All right, so adding x and 35x, the coefficient of x is 1, so 1 plus 35 is 36. So this would be equal to -9x plus 2 times 36x minus 28. Okay, so now we can use the distributive property again. We want to multiply 2 by 36x and then multiply 2 by -28. So this will be equal to -9x plus 2 times 36x, and then you'll add that to 2 times -28. All right, now I'm going to continue my work over here. This will be equal to -9x, and then we need to multiply 2 by 36x. So 2 times 36 is 72. So you'll have 72x as the next term. So plus 72x. And then 2 times the -28 is -56. So we have minus 56. All right, now you might be tempted to stop there, but we do have 2 like terms that we need to combine yet. Notice that -9x and 72x have the same variable part of x, so we can combine them. You can add their coefficients. And -9 plus positive 72 is positive 63. So our final answer here is 63x minus 56. That is the fully simplified form of this variable expression. Okay, so I know that this variable expression might have looked very complicated at the start, but hopefully now you can see that if you break it up into small pieces, you do one part at a time, starting from as far inside of a set of parentheses as you can get, it's not too bad. Okay, but that is it for this lesson. If you do want to get some more practice simplifying variable expressions using the distributive property, feel free to check out the examples video for this topic. I'll have it linked here on the screen. If you have any questions, please let me know in the comments. But if you don't have any questions, this is all I had for now, so I will see you next time.